All right, welcome to the last video for chapter 5.3, which is our lesson on the side-angle side theorem. So we have this quilt pattern here that's made up of triangles. We know that the segment PS is parallel to the segment QR, and also that PS is congruent to the segment QR. We want to use the side-angle side congruence theorem to show that triangle PQR is congruent to triangle RSP. All right, so PQR is this gray triangle here, which I'm actually going to color in yellow. And RSP is the triangle kind of right next to it. So our goal is to show that the yellow and the orange triangle are congruent. Okay? Same size, same shape. All right. So to do this as simple as possible, I'm going to try to do it in just 4 statements. Okay. Statement number 1 is going to be about a pair of congruent sides, and then a pair of congruent angles, and then a pair of congruent sides, and then statement 4 is going to be about our triangles, which I already know what that statement should look like, so I'll write that in. Okay. Triangle PQR is congruent to triangle RSP, and I already know what reason or theorem I want to use to prove this. It's the side-angle side theorem. So my job is going to be finding these pairs of congruent sides and angles. So let's go back to the information that we were given, right? We were told that side PS was congruent to QR. Okay, so PS is congruent to QR. Let's go ahead and record that. PS is congruent to QR, and that information was given. All right, we now have to find a pair of angles and then another pair of sides. Okay. Now to find the angles, we'll use this information, right? PS is parallel to QR. So I'm going to put the little red arrows to show that those are parallel lines. So we have these 2 parallel lines, and we can think of this diagonal line as a transversal. And what we remember about transversals is that the alternate interior angles will be congruent. Right? So I can claim that, let me call this angle number 1 and angle number 2. Right? I can claim angle 1 and 2 are congruent because they're alternate interior angles. Angle 1 congruent to angle 2, alternate interior angles. Okay. So I've got one side, I've got one angle. Now we need another side. Well, that that next side, if we follow the pattern, side, angle, side, side, angle, side. So the last side is going to be this diagonal segment PR. Okay. Now notice that PR is a side, is the name of a side in the yellow triangle, and PR is also the name of a side in the orange triangle. Right? They actually share this side. The 2 triangles are kind of fused, or they share that side PR. So what we want to say is that PR from the yellow triangle is congruent to PR from the orange triangle. But really, it's the same segment. PR is just PR. It should be congruent to itself. And so the mathematical property that allows us to say that things are congruent to themselves or things are equal to themselves, that is the reflexive property. So I'm going to put a double tick mark there, right? Just to show or remind myself that this diagonal segment belongs to both the yellow triangle and the orange triangle, but because it's the same segment, of course it's going to be congruent to itself. Okay. And so there's our pattern, right? Again, side, angle, side, side, angle, side. That's it. That's the last example. Notice all these examples we did here used the side angle side theorem, right, as our reason or as our evidence for why the triangles are congruent. Okay, and so this is awesome because previously we were having to show that all three sides were congruent and all three angles were congruent. So that was like 6 steps before we can write the statement about the triangles, which was a lot more work. Okay, the side angle side theorem really cuts down the amount of work that we have to do. It cuts down the amount of steps we have to show, making the proofs a lot more manageable. So I hope you found these videos helpful. I look forward to seeing you guys in the Zoom meeting.